people. So today, just want to talk to you about my adventure designing and producing my own PCB for. I'm using it for my NeoStrip rear LED project that I've been creating. So I found that I'm not into mass production here, but I've produced a few of them and sold a few of them, and the effort of soldering the wires, like I've been using this spaghetti approach to solder this thing together, and it's a lot of work. Majority of the work is actually just putting together all the bits and wiring things together, and I'll show you that in a second. But I wanted to show you sort of really quickly the PCB piece, and then I'm going to flip over to showing the finished product. So this is just showing I use fritzing to actually design the actual PCB, starting with a schematic. That's usually the approach I'll take, and this is my first time, by the way, so bear with me. And this is just showing that PCB design, just some components where you've got the C-jow unit, an actual opto coupler here. This area is the power supply, converts 12 volts coming from the car to 5 volts to power the microcontroller, as well as the connector which goes out to the LED strip. And in terms of input, it's got uses 12 volts coming from the actual running lights, and when you apply the brakes, it also watches, so to say, another 12 volt signal to trip another feature or function of the NeoStrip. And then there's a couple of things like a mode button to switch modes. And I've added a little breakout here in case for future updates I want to add a few components or add something powered, a powered component of some sort. Anyway, playing around. So I wanted to show you that, and that shows you the PCB design piece. And then I decided to use GLC PCB to actually do to create the PCB itself. I'm not sponsored by them. I just was looking around, and I found, honestly, for a newbie like me, that just their process for uploading and quoting and specifying the features of the PCB was really easy to use. And this, I just wanted to show that really quickly here. But when you start with their website, you ask for, basically request a quote, you upload your generated Gerber files, and it shows you the top and bottom of your PCB. But one of the features I really liked was this Gerber Viewer, which really kind of brought it home for me too. Was they have again, they show you the various views you can turn on and off layers, top and bottom views. But this one is one that I really liked, was the sort of the 3D view of the board, where you can really get a sense of what you've created, right? And you can look at the traces and whatnot and compare them front to back, which I found just being able to flip it around was really useful to me. And here we have the final product of the PCB board I created. I don't know how well you can see that, but that's the output from the GLC PCB process. So what I was doing is my original board. This is one version of an earlier version of the NeoStrip's controller. You'll see a similar design and layout for what I have here, but basically the controller, power supply, the actual opto isolator is here, and then the output to the LED and input from power there. And then it's hard to see, but I do all my soldering on the top. But let me just pop this off. The real effort, the reason why I wanted to do this, which was actually not that hard to do, if I can just get the controller out, is that you can't see it all, but there's a lot of wires that I had to do soldering of, and even some of the components. But there's a lot of component soldering as well as wire soldering, like cutting short runs of wire, soldering each side, running it through, soldering it through. The spaghetti approach to soldering. This has been my latest approach for the last few years for designing my boards and whatnot. And then I always usually make things removable in case I give up on a project or move on from a project to something else. So anyway, that's the approach. That was what I'd made by hand completely, and I wanted to transfer that to a board design. So this is the output of that design. I'm using a C-jow ESP32 unit here as the controller, and you'll see here again, there's the power supply, the Wi-Fi thing, power supply there, and then the input from the brake running lights and the output to the LED strip. So a much cleaner design. It took far less time to solder this because other than adding a few resistors, you can see in here the opto isolator there and the LED and a couple other components. It was relatively quick to actually put together, and that was my goal, just to make it a little faster and actually have something a little more solid that I can, you know, easily reproduce if I need to. Again, really impressed with the produced quality of this GLC PCB. There's lots of the others out there, but I just found, you know, the price was right, and their process, at least for somebody that's new like myself, just works for me right for now. Anyway, thanks for watching.